Well, welcome everyone. I'm JJ. Let's just jump in and tackle an example problem. So this one, we're starting out looking at 3D vectors. So we have just a random vector that we've drawn in here. We're saying for our following, let's figure out an expression for our position vector. We're going from A to B on this. Let's determine what is the distance from A to B. And then let's make a unit vector that points in the same direction as this random line that we have here, or arrow that we have drawn there. If we're doing this, let's just start with our position vector. So if we're making position vectors and we have coordinates, we always want to do the coordinates of the tip minus the coordinates of the tail. Always tip minus tail. So if we're looking at this, the tip should always be the point that has the arrowhead on it. So in this problem, B is our tip. The other end without the arrowhead is going to be the tail. So A is our tail. So if we're doing tip minus tail, I want to do the coordinates of B minus the coordinates of A. So let's just find both of those. So coordinates of B. Coordinates of point B. So we're going to start at the origin and just kind of trace our way out. In the x direction, we'll get it first. I'm going to follow a line so I can get an x dimension here. I'm going back 2 feet. Our positive end is out here, so I'm going -2 in the x. -2. In the y from the origin, I'm coming out here 5 feet, so -2, 5. And the z direction, I'm going up 8 feet. So -2, 5, 8 feet will be my coordinates for B. And we're just going to repeat that for A. Coordinates of A are going to be, again, let's start at the origin and just trace our way out. In the x direction, I go 3 feet, so 3. In the y direction, I'm going to the left or in the negative direction 2 feet, 3, -2. And in the z direction, I go up 5. 3, -2, 5 feet. If we're looking for our position vector then, all I want to do is come in and just say I want to do the coordinates of the tip minus the coordinates of the tail. So I'm looking for a position vector that's an R that goes from A to B, and it's a vector. So RAB, from A to B is how we'd be reading that. That's really, again, our coordinates of B minus the coordinates of A is all we need to put in as we calculate that out. So this is, we'll just do each component one at a time here. -2 minus 3. -2 minus 3I. Plus, then we get the J component. -2 minus 5. So I did that the backwards, didn't I? 5 minus a -2. B minus A. 5 minus -2, which will become a plus in here. That's our J. And then we get our K, plus B minus A, 8 minus 5, K, and again our units for the whole thing are feet. If we have that all set up, we can come in and just evaluate it. What's the numbers actually work out to get us to? This is RAB. Should be -2 minus 3 is -5, so -5I. 5 minus a -2 should get us 5 plus 2, so plus 7J. And then 8 minus 5 should get us 3, plus 3K feet. Which is our answer for that first part. What's our expression for our position vector? R something here. R means position vector. Our next step was, what's our distance from A to B? If we figure out the magnitude of a position vector, we're going to get the distance for anything. So our second step, really all that I'm looking for here is, what is the magnitude of our position vector? RAB, magnitude is what we're getting out from this. And this is, we can use the Pythagorean theorem. We're in 3D for it. So I have -5 squared. It's the same as 5 squared. So 5 squared plus 7 squared plus 3 squared. Which again, I can punch that whole thing into my calculator. I'm going to get that the magnitude of RAB, our distance from point A to point B, is 9.11 feet, which would be our second answer for this. Finally, we're asked, can I get a unit vector that points in the same direction? So some unitless vector that points from A out there towards point B. Should have a magnitude of 1. We're just going that direction with it. Really, all I need to do is come in and say, we worked with force vectors to get unit vectors before. We said a unit vector was our force vector divided by our magnitude of our force vector. It's the same idea here. Our unit vector is a position vector. We'll work with RAB as a vector divided by the magnitude of RAB. Really, a unit vector is a vector divided by its magnitude. We'll get us there every time. So this is our unit, or our position vector was negative 5I plus 7J plus 3K. And we'll divide by the magnitude, which we just found, 9.11. We'd have feet for our units on the top and on the bottom. Those will cancel out and leave us with our unitless vector, or unit vector. UAB, our unit vector, should be negative 0.549 in our I direction, plus 0.768J. I'm just doing 5 or negative 5 over 9.11, 7 over 9.11, and then plus 3 divided by 9.11 is plus 0.329K, which will be our last answer for our problem. Where we're going to go with this, just so we have a little bit of a heads up, is we can find unit vectors here. Ultimately, we want to work with forces for statics here. If I take a unit vector and I told you this is actually a force vector, maybe it's a 500-pound force. If I multiply this by 500 times negative 0.549, 500 times 0.768 times 0.329, you give me a force vector, a Cartesian force vector in 3 dimensions. It makes our math a lot easier to work with if we can get to a unit vector. So there's a lot of value in trying to get here, and that's a smaller step to actually find our force vector from there. But that's where we're going with that. If this is useful, go ahead and hit that like and subscribe button. Let's get Q&A with JJ.